Hi, my name is Tejas Kumar. I'm part of the group including James, Des, and David. My role in the project was to try and help implement the neural network onto an FPGA device, or a fully programmable gate array device. Now the main question is, why would you want to implement a neural network on such a device? And the main reason is to reduce latency at the cost of precision. You may think that precision is the most valuable aspect, but in many applications, speed of the results is much more important. That's why you'd implement it on a fully programmable gate array instead. Another reason is it's much cheaper and less time consuming than to design a neural network based on a VSLI chip. So that's the main reason we're trying to implement it onto an FPGA. To learn how to do it, the main task that I had to first figure out is how a fully connected neural network works. And it works by taking an input layer and an output layer, and in between are a bunch of hidden layers. And each step of the layer, it basically uses a probability to see which node transmits data to the next layer. And the main computational hardware required for each layer is just matrix multiplication. So the goal is to try to figure out, as the semester progresses, how to implement a matrix multiplication onto a FPGA board, and also how to read the bias and values from the actual computational device onto the FPGA. Thank you.
Hi, I'm James. I am on the team with Tejas, David, and Des. We are implementing a quantized neural network on an FPGA. I've been handling the neural networks. When training on something simple, like the MNIST handwritten digits dataset, a simple artificial neural network is relatively easy to implement, but the accuracy is a little bit lower, down to 92%, which isn't as great as something like a convolutional neural network, which uses a trained filter to stride across the image, which improves results up to 98% accuracy. For the quantization, we're turning a 32-bit number into an 8-bit number, which greatly improves the amount of space that a model takes up. A quantized model is about 3.5 times smaller than a precision model, which is great for using on FPGAs. Thanks.
Hello, I'm Desiree Black. I'm part of the team Practical Neurons. My role on the project is to discuss LaFlow. Mapping neural networks to hardware isn't quite possible directly, so LaFlow is an open source tool flow that maps numerical computation models written in TensorFlow to synthesizable hardware.
I'm David Perez, majoring in electrical engineering. In the upcoming weeks, we'll be giving the FPGA images from a dataset and begin to train the neural network. We'll also be focusing on the quantization process of the neural network and decide on the data type size. Having a larger data type size typically maximizes accuracy, but smaller data type sizes can have competitive and sometimes better accuracy results while being faster at computation. If experiments show that a smaller data type size can be used, this method will perform faster and heat up less than a product that uses the floating point precision.